In this series of video, we will talk about Tensorboard. Now, while I was discussing TensorFlow library, one of the advantages I mentioned of using TensorFlow is that TensorFlow provides a visualization which is called as Tensorboard. So everyone agrees that visuals are better than text. Visualization offers flexibility and interactivity in any kind of interpretation. And this is one of the advantages of TensorFlow library when compared with other deep learning or machine learning libraries. That is, the TensorFlow provides with visualization boards. Tensorboard is a visualization software that comes with any standard TensorFlow installation. Now, if you remember from the TensorFlow discussions, we know that the TensorFlow programs can range from a very simple to a very complicated problems which has thousands of computations. And in a TensorFlow, there are two basic components for any TensorFlow programs, which is operations and tensors. The idea is that you create a model that consists of a set of operations, and data is fed into the model, and the tensors will flow between the operations until you get an output tensor, which is your result. So your nodes are, if you consider a computational graph, which again I have showed an example of while we were discussing TensorFlow, if you visualize a computational graph in your mind, the nodes in your computation graph are what is called as operations, because they represent an operation like an addition or a multiplication. Whereas the edges to these nodes, or the vertices, what we call the edges of these nodes are what is called as tensors. So tensors are nothing but they are the carrier of our input and our output. So TensorFlow provides Tensorboard, and Tensorboard provides us with a suite of web applications that helps us to inspect and understand the TensorFlow and how the TensorFlow computational graphs are being constructed. Now, in Google's word, the Tensorboard is defined as the computations you will use TensorFlow for many things, like training a massive deep neural network, and they can be complex and confusing. To make it easier to understand, debug, and optimize a TensorFlow program, we have included a state of visualization tool called as the Tensorboard. So this is what the Google's version of Tensorboard is. So if we know that TensorFlow is a library developed by Google, and Tensorboard is again a visualization tool that comes along with this TensorFlow library, which is again created by Google. So this is what the Google's version or definition of Tensorboard is. Now, Tensorboards was created as a way to help us understand the flow of tensors in your model so that we can debug and optimize it. And the Tensorboard generally has two main purposes. The first one is the visualization of the graph, or the visualization of the model that we are creating, or the visualization of the model that we created in the form of a computational model. Right? So that is one purpose why we use the Tensorboard, to visualize our computational graph which we have created by a TensorFlow program. And the second main purpose of TensorFlow is for writing summaries to visualize learners. So we will take a look at each of these two purposes separately. So for example, the first major reason of using TensorFlow is to visualize the computation graph. And this is one example of a computation graph, or more precisely, this is an example of a model that is built with the help of convolutional neural networks. So that's something we will start learning when we dive deep into computer vision. For the time being, just understand that it gives you a picture of how our model works, right? How the deep learning model that we have built actually work, and how the operations are present in each of our computational graph, and what are the inputs to these operations. So what you see as node in this computational graphs are operations, and the edges that connects these operations are what is called as tensors. That is, through these tensors, the input and output from one node to another is transported. So let us start working on a simple program just to add two numbers and try to visualize the graph of that computational model with the help of Tensorboard. So let's get started. One reason that I'm introducing Tensorboard in this course is because I believe learning to use this Tensorboard at a very early stage in the course could sometimes help you to work with TensorFlow in a more, I would say, enjoyable and productive way if you are someone who is very fond of visualization. So even though this is not explicitly mentioned in your course outline, I personally feel that it is an important and integral part of TensorFlow, and that has to be addressed in the class. So as I have mentioned, we will first look into the first important reason for using Tensorboard, that is to visualize the computational graph. Now, these computational graphs can go from very simple graphs to very complicated graphs. And visualizing these computational graphs can help us understand and debug our program. So to start with, I have written a very small program. So in the first cell, you can see I have written a simple TensorFlow program to add two numbers. So you can see I have my tensors A and tensor B and tensor C, right? So my tensor A has a constant tensor, or is a constant tensor, and has a value 2, and B is another constant tensor with a value 3, and then I have defined an operation which is called as add, that will add my two tensors A and B and save the result in another tensor called as C. And then I am running this particular TensorFlow session. So I have given the constants to be 3 and 5. So for example, I give 5 and 3, and if I run this program, I should get the output of 5 plus 3, which is 8. So as you can see, I get my output to be 8. So I have now written by this few lines of code a TensorFlow program to add two numbers. Now next, what I'm trying to do in my next lines of code is that I'm trying to make this particular TensorFlow program in order to add two numbers to be Tensorboard activated. And in order to do that, I need to add some few additional line of code. And that is what you can see in the second code I have written. So I have rewritten my TensorFlow program to add two numbers to make it Tensorboard activated. As you can see, the only extra line of code I have added is this one, right? So what I have written in this extra line of code is that will help me export my TensorFlow operations into a file. And this file is what is called as an event file or an event log file, right? So in order for your Tensorboard to be activated, your TensorFlow operation has to be exported into a log file, and writing this line of code will help me create my log file. The Tensorboard, so I have created a log file called as graphs, and the Tensorboard will read this log file which I have created in my folder called graphs and will give insights on my computational model and its performance. So let us go ahead and run this code which is now Tensorboard activated and visualize the computational graph for this particular TensorFlow program. So I will go ahead and run this cell. So I am adding two numbers 2 and 3, but now I have activated my Tensorboard. Now once you run this program, the next step you have to do is to activate my Tensorboard. So in order to do that, I open my Anaconda prompt. So I again hope everyone are familiar with executing programs or running programs through Anaconda prompt. If not, just open your Anaconda terminal and go to the folder in which you have this particular Python program written. So for me, this is in downloads. So as you can see, now my path changes to user NUPA downloads. Now in my downloads folder, my Python code I have just now written is present in another folder called as week. So another folder called as week 2. So I will go to cd week 2. So now you can see my Anaconda prompt is pointing to the program to the folder wherein which I have my my Python file written for this particular program. Now once you execute your file, you would see that I now have a new folder in my computer which is called as graph. So if you click this graphs folder, you could see a log file. So this is what the log file that we have created in order to activate my Tensorboard. Right? So let us now go ahead and try to get the Tensorboard running on my computer. To do so, I need to use a command python -m tensorboard.main -log dir equal to graph. So remember, in the program I have given graphs to be the folder wherein which I need my log file. So that is why I am giving it as log directory is equal to graphs. Now I will press enter, and if everything goes fine, that means if you have the Tensorboard installed in your computer and if your program does not have any error, what happens is that you will get a message like this, which says that you can access the Tensorboard on your computer through localhost at the port 6006. So by default, that is the port which the Tensorboard uses. So what you can do is go to open a new terminal in your browser. I use Chrome, so I go there and I type localhost 6000. I type localhost 6000 and you would see shortly that my Tensorboard gets loaded. It might take a while. So if your Tensorboard is up and running at localhost port 6006, then this is what the computational graph you will get for the program that we have just implemented. So we know const and const_1 in the graph corresponds to our variables that we have used called A and B. So for TensorFlow and Tensorboard, these variable names that we give in the program like A, B, C, etc., which we have provided in the program, means nothing. So to make Tensorboard understand the names of our operations, we have to explicitly name them. So we will see how that can be done. But this is pretty much the Tensorboard. Again, I have implemented this Tensorboard only for graphs or the computational graphs. That is why you just can see one tab here. Now you can have, if you are someone who is looking for visualizing the histograms, so that comes in the summarization process. So if you also have that part of the code you have written, you will have more tabs that appears here. So since for this particular program I have just constructed a Tensorboard to visualize the computational graph, I just have this tab called as graph. So again, feel free to navigate through each of these and see what each of these means. And there is one also, you can download this particular image if you want to share that in a PPT. You can also download it from here. So we will go ahead and see now how I can change this const and const_1 to the variable names we have used in our program, which was A and B. So to do that, the only thing that I have to add is I have to add I have written a new program which is the same as the one before. The only thing I have added is I have added here comma name is equal to edition. So let us go ahead and run this. And also one more thing you would notice is that every time I run my program using the same the log file folder, you could see that in the graphs folder now I have one more log file, right? So uh, uh, if you don't require the previous log file, you could just delete it, or if rather than graphs, what you can also do is change the name of the folder in which you have your log file. But if you are using the same folder like what I have shown, what happens is that the TensorFlow automatically use the last one which was executed. So here you can see I got my first log file at 326, the other 256, other at 313. So it will always run the latest log file that has been created. So let us go ahead and rerun my program. So I will just have Control C to quit from here, the same command to rerun my program. Now you can see that in my computational graph, see the const and const underscore 1 got replaced by my variable name or the tensor name I have used in my program, which was A, A and B. And then the name of my operational node is also changed from add to addition, right? So this is one important aspect of having Tensorboard to actually visualize the models that you are building. So we have just built a small model, not even a model, but just a small program to add two numbers. So imagine what it can do for you when you are actually building a very dense deep neural network. So it will actually show you that entire computational graph. I will share this program with the class so that you could just rerun it and get a glimpse of how a Tensorboard looks like. But again, beware, before even you can run this program, you should have Tensorboard installed in your laptop, right? If you are using Anaconda, it should be installed from your Anaconda prompt. And also you should make sure that sometimes what happens is that the Tensorboard throw you an error, and most probably it will be because of the cookie setting of your browser. So also make sure that if you run with any errors, check how your cookies are being set in your browsers, right?